Hello students, good morning. Today I am going to discuss class 9th mathematics. In the last class we already discussed about the irrational numbers. We are proving the irrational numbers by using contradictory methods, and we are making the ascending and descending forms of the irrational numbers. We are comparing the irrational numbers. We are finding rational numbers and irrational numbers between two given numbers. Okay, so in this class we will discuss about the next concept, that is surds or radicals. So surds or radicals means irrational roots of a positive rational numbers. Irrational roots of a positive rational numbers is called as a surds or radicals. Irrational roots. So you already know in the previous classes irrational numbers: root 2, root 3, root 5, root 6, root 4. Is it root 4 irrational number? No, because the square root of root 4 is 2. That 2 can be represented as 2 by 1. So it's a rational number, therefore root 4 is not a irrational number. But here root 2, root 3, root 5, root 6 are the irrational numbers. Which type of irrational numbers they are? They are the positive irrational numbers. Okay, so the irrational roots of the positive rational numbers. Positive rational numbers are called as a surds or radicals. For example, nth root of a. How you can read this one? Nth root of a. In that, n is called as index. N is index or power, and a is base. A is base or radicand. N is the index or power, and a is the base or radicand. For example, cube root of 5, square root of 8, fifth root of 8. Here n is equal to 3. It means the power of the surd or the power of the radicals is 3, and base is 5. What we have now here, the surd or radical, the power of the radical is 3 and the base of the radical is 5. Here the power of the radical is 2, n is equal to 2, and base, that is a, is equal to 8. Next one, n is equal to 5 because the power of the radical is 5 and a is equal to 8. Okay, here n is called as a index or power, a is called as a base or radicand. If I am writing all the numbers in this format, all that we are considering, is it as a surds or radicals. For example, root 4, is it surd or radical? No, because the exact value of root 4 is 2. We can represent in the form of rational numbers, that is nothing but a 2 by 1, which is in the form of p by q. Therefore it is not a surd or radical. So radicals, how we can identify the radicals, or what are the conditions are there to identify the radicals? First condition is n means the power of the radical. N means the power of the radical. Power of radical should be greater than greater than 1. The power of the radical should be greater than 1, then only we are considering it as a given numbers or radicals. Okay, so this is the first condition. Second one, A means index or base. Index or base must and should be positive rational number. Positive rational number. It means here we have some examples. 3 is a power of the radical here which is greater than 1, and 5 is a rational number. 5 is a rational number and it is purely positive rational number. If you are considering the negative rational numbers, means they are not considered as a radicals. Okay, next one, 8 is the positive rational number and power of the radical is 2. Square root, square means multiplying the same number 2 times means, so square root its power is 2. Next one, fifth root of 8. So what is the power of radical here? 5. So 5 is greater than 1 and 8 is a positive rational number. Next, third condition, they are all non-terminating and non-recurring decimals. When we are finding their result, they are purely non-terminating and non-recurring radicals. Non-repeated, non-terminating and non-recurring. We already discussed in the previous classes in the irrational numbers, and in the last classes rational numbers were already discussed about the terminating and non-terminating and non-recurring, right? So once we are finding the values of this one, they are purely non-terminating and non-recurring numbers. So these are the three main conditions, but we need to apply first two conditions must and should. First one is n should be, it means the power of the radical should be positive and it is always greater than, it should be always greater than 1. And second one, what is that second condition? The base or radicand is always be a positive rational numbers. Okay, let's see here some examples. Root 4, is it considered as a radicals? No. Root 4, what is the value of root 4? 2. 2 is not a irrational number. Once we are getting the irrational number, then only it is a radical. Okay, so 2 is a rational number. Why? Because the denominator of 2 is always 1. So it is not a surd. Next, take one more example. Cube root of 8. Cube root of 8 value is 2. So 2 is again, it is also not a surd. So these type of, it means the perfect square roots and perfect cube roots are not considered as a surds or radicals. For example, root 1, root 4, root 9, root 16, root 25. All these perfect squares will not be considered as a surds. Next one, all the perfect cube roots, cube root of 1, cube root of 8, cube root of 27, cube root of 64, cube root of 125. So all these are not considered as a radicals or surds. Or fourth root of 1, right? So these kind of the irrational numbers are not considered as a radicals or surds. Okay, next one, if the order of the radical is 2, then we call it as a quadratic surd. Okay, next, nth root of a. nth root of a. How you can write this one? Nth root of a, it can be write it as a raised to the power 1 by n. A raised to the power 1 by n. So this is the radical form and this one is the exponential form. Exponential form, and this is radical form. This is radical and this one is the exponential form. So I will give some examples in the radicals form. You need to write that examples in the exponential form. You need to express the followings in the exponential forms. Okay, first one, cube root of 2. Second one, fourth root of 5. Third one, fifth root of 20. So express these given numbers in the exponential form. How you can express this one? 2 raised to the power 1 by 3. 2 raised to the power 1 by 3. Cube root means 1 by 3. Okay. Next one, 5 raised to the power 1 by 4. Fourth root. Next one, 20 raised to the power 1 by 5. Like this you can express the following radicals in the form of exponential forms. Okay. Next one, here some questions are given. State which of the followings are surds. Some questions are given. You need to identify whether the given questions are surds or not. Okay. First one, root 48. Second one, root 225 into root 4. Third one, root 121 into root 16. Fourth one, root 200. So need to identify which of the following is a surd. Okay. See the first one, 48, root 48. How you can split the root 48? 16 into 3. I already told you in the previous classes, when you are splitting the rational number which is existing in the inner part of the square root, the one, at least one separated number should be the perfect square numbers. So 16 3 is a 48. Now here 16 is a perfect square number. Square root of 16 is 4 root 3. 4 root 3. Next one, simplify the second one. What is the square root of 225? Square root of 225 is 15. Square root of 4 is 2, which is equal to 30. Next one, 125. Square root of 125 is 11. Square root of 16 is 4. 11 4s are 44. Square root of 200 is, how you can split the square root of 200? 100 into 2. Okay, 100 into 2. In that, square root of 100 is 10. 10 will come outside, remaining root 2 as it is. So now you can classify easily which one will form surds and which will not form a surd. So first one is surd. It is a surd. Second one, it's not a surd or radical. So it is also not a surd. It's also not surd. And fourth one, it is surd. Okay. So these are the some examples. With the help of these examples, we are identifying which of the given numbers or given irrational numbers will form a surds. Okay. Next one. See here, one more question is there. Just check it out whether it will a rational number or irrational number, and also find whether the given number is formed surd or not. The given number is root 25. So root 25, is it form surd or not? What is the value of root 25? 5. 5, is it form surd? No. So because it is in the rational form, usually the rational numbers will not form a surds. In the pure form, 5 is the purest form of the rational number. It can be represented in the form of pi by 1 or 5 by 1. It can be represented in the form of p by q. So root 25 will not form a surd or radical. Next one. See the next question. Root 140. Can you split the root 140? Must and should. While you are splitting the square root values, at least one number, at least one factor should be the perfect square number. So can you split 140? 70 into 2. Here 70 is also not a perfect square and 2 is also not a perfect square. It means, is there any other factors to finding the root 140 is a forming radical or not? No. Because it is not a perfect square number, root 140, it is not a perfect square number. So which is the nearest perfect square number here? Root 144, it is a perfect square of 12. So root 140, which is not a perfect square number. So 140 will not form a radical. It is not form a radical, not form radical, or it is not an example for radicals. Okay, next one. See the next question. Next type questions is rationalizing of order 2. For your syllabus, you need to rationalize the surds of order 2. So rationalizing means what? Rationalizing means what? The product of the irrational numbers. The product of the irrational numbers forming a rational number is called as a irrational numbers. The product of the two irrational numbers. The product of the two irrational numbers, while we are multiplying, or when we are multiplying that two irrational numbers, we will get it as a rational number. So that process is called as a rationalizing. And the involving irrational numbers are called as a rationalizing factors. Okay, see one example. Root 5 into 2 root 5. I already told you, root a into root a, which is nothing but a, right? So a can also be written as root a into root a, right? Here root a into root a is equal to a, and a square is equal to, how you can write this one? A square is equal to a into a square. A square, square root of a square is square and root get cancelled, remaining a. So these are the some basic laws in the radicals. Okay, now root 5 into root 5, 5, remaining 2 as it is. So what you will get, that answer 10. Okay, here 5 and root 5 are called as a rationalizing factors. Rationalizing factors, and 10 is called as a rational number. Okay, so rationalizing means what? It is the product of the two irrational numbers. It's the product of the irrational numbers. When we are multiplying the irrational numbers, we get it as a rational number. So that process is called as a rationalizing. In that, the involving irrational numbers are called as a rationalizing factors, and what we are getting, the product or resultant, is called as a rational number. Okay, next one. See the next question. Find the least rationalizing factor. Find the least rationalizing factor. If you are finding or if you are converting irrational to rational number, means you need at least one or two irrational numbers. So here in given questions you need to identify at least how many numbers you will be need to make an irrational number as a rational number. Okay, see the first question, root 27, root 48, second one, third one, root 200, fourth one, root 80. Here some questions are there. For these questions you need to find least rationalizing factor. Okay, I can split the root 27, square root of 3 into 9 into 3. In that, while you are splitting the rational number which is existing in the interior part of the square root, it means the square root of root 27 can be split it as 9 into 3. One number, at least one number should be perfect square number. So here 9 is a perfect square number. The square root of 9 is 3 root 3. Again it is in the form of irrational number, but we need to convert it as a rational number. Then what we need to multiply to converting the 3 root 3 as a rational number? We need to multiply one more, that is root 3. Root 3. So 3 in 3 write as it is, root 3 into root 3, 3, that is equal to 9. Here the 3 is called as a least rationalizing value or number. This is the required list, at least one number. In some problems we need two rationalizing list of two irrational numbers. Okay, next one. So root 3 is called as a rationalizing factor. With the help of this only we will get it as a rational number. So root 3 is called as a rationalizing factors. Now find the second one. Find the least rationalizing factor of root 48. I can split the root 48, 16 into 3. So square root of 16 is 4 into root 3. What we need to multiply to convert it as a rational number? Root 3. So root 3 into root 3, 3. Remaining 4 as it is. 4 3s are 12. Here, so 12 is a rational number. 12 is a rational number. Again here 9 is also rational number. Next one. See the third question. Root 200, split this one, root 200, square root of 200 can be split it as 100 into 2. Square root of 100 is 10, 10 into 2. So 10 into root 2. So what is the least rationalizing factor? What we need to multiply here? Root 2. Root 2 into root 2 is 2. Remaining 10 as it is. 10 2s are 20. So 20 is a rational number. Okay. And the least rationalizing factor is root 2. Similarly simplify this one. Square root of 80. Square root of 80 can be split it as 16 into 5. 16 into 5. In that square root of 16 is 4. Remaining root 5. What we need to multiply here? The one more rationalizing factor is root 5. So rationalizing factor root 5 into root 5. 5 into 4, which is equal to 4 2s are 24. 5s are 20. So 20 is a rational number. 20 is a rational number. From all these examples, we conclude that if you need to rationalize if we need to converting the irrational number as a rational number, we need to multiply some rationalizing factors. In some problems we are multiplying single irrational number, in some problems we are multiplying two or more than two irrational numbers. Okay, we will discuss in the next concept, that is the rationalization of the denominators. Okay, see the next one, the next concept is rationalization of denominator. Rationalization of the denominators. In the rationalization of the denominator, we are multiplying the least rationalizing factor and convert it as in the form of the rational numbers or irrational numbers. Okay. Next concept is rationalization of denominator. Rationalization of denominator. See the first question. Rationalize the denominators. Rationalize the denominators of first one 1 by root 7. Second one 2 by 3 root 5. Third one 5 by 4th root 3. 5 by 4 into root 3. Okay. Some simple problems are there. You need to rationalize their denominators. Okay. How you can find the rationalizing the denominators? 1 by root 7, 2 by 3 into root 5, 5 by 4 into root 3. While you are finding the denominator rationalization, just concentrate on the denominator part. The least denominator, what we already discussed, no? The least rationalizing factor we need to multiply for the given question, and we will convert it as a rational number or irrational number. So we need to multiply the rationalizing factor of the denominator for both numerator and denominator. We are multiplying the denominator value for both numerator and denominator. Okay, root 7 into 1, root 7, root 7 into 7, 7. So this is the rationalized form of the first question. Second one 2 by 3 into root 5. What we need to multiply here? Least rationalizing factor is root 5 divided by root 5. 2 into root 5, 2 root 5, root 5 into root 5, 5 into, write this 3 as it is, 2 root 5 divided by 3 5s are 15. Okay. Next one 5 divided by 4 root 3. Write this 5 as it is, divided by 4 root 3. Now rationalize the denominator. Rationalize the denominator means we are multiplying the irrational number or at least required rationalizing factor for both numerator and denominator. So root 3 into root 3, 5 into root 3 is 5 root 3 divided by root 3 into root 3, 3 remaining 4, 5 root 3, write as it is, 4 3s are 12. So these are the required rationalized form of the given questions. Okay. Next one, see the next question. Simplify each of the following by rationalizing denominators. In that first one 1 by 3 minus root 2. Second one 3 by root 5 plus root 2. Third one root 3 minus root 2 divided by root 3 plus root 2. Fourth one 5 root 2 divided by root 3 plus root 5. So rationalize the denominator. Simplify each of the following by rationalizing denominators. Here 4 questions are there. We need to rationalize the denominators. Before solving these 4 questions, I will take one more example. 1 by root 5. How you are rationalizing here? You are multiplying the root 5 for the both numerator and denominator. Root 5 into root 5. 1 into root 5 is root 5 divided by root 5 into root 5 is 5. So this is the rationalized form of the 1 by root 5. Observe here, in the given question only one radical, one third or one radical is there in the place of denominator. So we are simply multiplying for the both numerator and denominator, and we will simplify the question, we will get the answer. In case of two radicals or combination of the two numbers, how you can simplify? When we are going to be rationalize the denominator with two radicals, either it is a combination of rational number and irrational number or irrational number and irrational number, we need to convert their signs. If it is in the positive term, we are converting it as a negative. We are taking the opposite signs between the two radicals or between the two factors. Okay, see the first one, we will get some ideas by rationalizing these questions. First one, 1 by 3 minus root 2. So this is the given question. You need to rationalize the denominator. Write the question once again. 1 by 3 minus root 2. What we have in the place of denominator? 3 minus root 2. So multiply. We need to multiply here the least rationalizing factor. So least rationalizing factor is 3 plus root 2 divided by 3 plus root 2. If we are having two rationalizing factors, then we need to take the opposite signs. If we have positive means we need to take it as a negative. If we are having negative sign means then we will take it as a positive. Here 3 minus root 2 becomes 3 plus root 2. No, multiply both numerator and numerator, denominator and denominator. So 3 into 1 is 3 plus root 2 as it is. 3 into 1 is 3, root 2 into 1 is root 2. And one more important is when you are rationalizing the denominator with two radicals or with two rationalizing factors, the denominator is always in the form of a square minus b square, or it is in the form of a plus b into a minus b. Just check the given example here. A minus b into a plus b. A minus b into a plus b. So how you can write the a plus b into a minus b? It can be written as a square minus b square. So 3 square minus root 2 whole square. Here 3 plus root 2, we cannot add these two, so write as it is. 3 square is 9, square and root get cancelled, remaining 2. So 3 plus root 2 divided by 9 minus 2 is 7. Okay, so this is the rationalized answer of the first question. Okay, see the next one. Second question, 3 by root 5 plus root 2. Directly rationalize the denominator. Root 5 plus root 2. What is the least rationalized factor here? Root 5 minus root 2 divided by root 5 minus root 2. Now 3 into root 5, or you can simply write it as 3 into root 5 minus root 2. Or you can multiply individual terms. 3 into root 5, 3 root 5 minus 3 into root 2, 3 root 2. Okay. Again, now the denominators are in the form of a square minus b square. So root 5 whole square minus root 2 whole square. Square and root get cancelled, square and root get cancelled. The numerator is again 3 into root 5 minus root 2 divided by square and root get cancelled means remaining 5. Square and root get cancelled, remaining 2. So 3 square root of 5 minus square root of 2 divided by 5 minus 2 is 3. 3 and 3 get cancelled, remaining the final answer is root 5 minus root 2. This is the required result by rationalizing the second question. We are getting the result by rationalizing the given second question. Next one. See the third question. Third one is root 3 minus root 2 divided by root 3 plus root 2. Okay, rationalize the denominator. What we need to multiply? The least rationalizing factor, root 3 minus root 2 divided by root 3 minus root 2. Now observe the numerator part, a minus b into a minus b. It is in the form of a minus b whole square. So root 3 minus root 2 whole square divided by, denominators are in the form of root 3 plus root 2 into root 3 minus root 2, a plus b into a minus b. So root of 3 whole square minus root of 2 whole square. Simplify the numerator with the help of a minus b whole square formula. Root 3 whole square minus 2 into root 3 into root 2 plus root 2 whole square divided by, square and root get cancelled, square and root get cancelled, 3 minus 2, square and root get cancelled, remaining 3 minus 2 into root 3 into root 2, root 6 plus square and root get cancelled, remaining 2 divided by 3 minus 2 is 1. 3 plus 2 is 5 minus 2 root 6 divided by 1. So this is the required result of the rationalized form. Next, see the next question, fourth one. 5 root 2 divided by root 3 plus root 5. Multiply or rationalize the denominator. Root 3 minus root 5 divided by root 3 minus root 5. Multiply the numerators first. Root 5 into root 2 into root 3. 5 into root 2 into root 3 is root 6 minus 5 into root 2 into root 5, root 10 divided by, now the denominators are in the form of a square minus b square. How you can write this one? A plus b into a minus b. So square root of 3 whole square minus square root of 5 whole square. No, we cannot add because we are having here two different rational numbers inside the radicals. So write the numerator as it is, root 5 root 6 minus 5 root 10. Square and root get cancelled, remaining 3 minus square and root get cancelled, remaining 5. Therefore the final answer is, here we will take 5 as a common. Once we take the 5 as a common, 5 into root 6 minus root 10 divided by 3 minus 5 is minus 2. So these are the some examples related to the rationalizing the denominator. Just practice these type questions, we will get some more ideas. Okay, in the next class we will discuss one new chapter. Until then, be happy, have a nice day, and thank you for watching.